Hello, welcome to Algebra 2 Homework Help. My name is Mrs. Rock. This is not a chance for you to copy the answers for your homework. This is your opportunity to take the information that you learned in your algebra class and to slowly process that information so that you can successfully complete the homework on your own. No one has ever accused me of going fast. This will be a slow process. Again, if your goal is to quickly do your homework, this is not the way to do it. During this video, I want you to, number one, listen to and watch how the homework problems are solved. Number two, copy everything onto a blank piece of paper. Number three, turn off the video and turn over your notes. And number four, try to do the homework paper on your own after listening to the video. You can look back at your notes if you need help. Let's begin. Today I am doing Algebra 2, M1T1, Applications of Graphing Quadratics. Do you have the same homework? Great. Let's begin. Let's start by looking at the graph on the right. Let's look at this graph. Let's label the parts even before we read the question. Let's look at the parts of the graph. I see the y-axis is labeled with height in feet. The x-axis is actually not labeled. We still need to know what this should be labeled as. Let's see if we can gather that information from the questions. The question says, a swim team member performs a dive from a diving board. The graph shows the path of her dive. A, how high was the diver after 6 seconds? So we already have the height on this side, so I can assume that the x-axis will be for time in seconds. So let's label that x-axis with time in seconds. What are some of the other points of this graph that we can label? I know the very top point on a graph is called the vertex. The vertex is also the very bottom of a graph, depending on how the graph curves. This point, where the graph crosses the y-axis or meets the y-axis, this one doesn't actually cross, is the y-intercept. I'm going to write y-intercept, kind of small. Y-intercept, I'm just going to point right there. The y-intercept is always where x equals 0. Then we have down here where the graph meets the x-axis. This would be the x-intercept. This is where y equals 0. What's another bit of information we can add to this? Straight down from the vertex, we have an imaginary line that is called the axis of symmetry. The axis of symmetry means it is the same on both sides. Let's see if we can already identify some of the values of these parts. The vertex, let's see, the vertex, the x value of the vertex is going to be the same value of the axis of symmetry. So I see that the axis of symmetry is at this point. So x equals 1, 2, 3. So the axis of symmetry equals 3. That means the x value of the vertex is 3. To find the y value of the vertex, let's just draw an imaginary line over to the y-axis. Let's see, how are these points labeled? It looks like they're labeled by 2. We can go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So I see that this vertex is between 22 and 24. That tells me that the vertex is 23. Our y-intercept looks like it's at where y equals 14. So our y-intercept, x equals 0, and the y is 14. And our x-intercept down here, let's see, can I make that a little bit clearer? That's a little bit better. Looks like our x-intercept, where y equals 0, x equals 8. So our x-intercept is 8, 0. Now that we have completed all of that information, it will be easier to answer the questions. The question says, a swim team member performs a dive from a diving board. The graph shows the path of her dive. How high was the diver after 6 seconds? So I know time goes along the x-axis. Let's go to 6 seconds. 2, 4, 6. How high is the diver at 6 seconds? It crosses the graph at that point. Let's see where that is. It looks like it is between 12 and 14. So how high was the diver after 6 seconds? The diver was 13, and the unit of measurement is feet. I know it's feet because it says it on the graph. Question B, how high was the diving board? Well, it looks like that this diver did not start on the ground. I would say ground would be 0.0 in the height. It looks like the diving board, she started on the diving board at 14 feet, right there. That would be the y-intercept. So the y-intercept is at 14 feet. Question C, after how many seconds did the diver hit the water? We can assume the water is at 0 on the 0 on the y-axis. Where on the x-axis does y equal 0? That would be at 8 seconds. And question D, what is the approximate maximum height that the diver reached? The highest point will be the vertex. Remember, the x-coordinate of the vertex represents time, and the y-coordinate of the vertex represents the height. So the maximum height is 23 feet. So we are done with question 1. I hope you are writing all of this on a blank piece of paper so that on your own you can come back and do it on your own. Okay, it is now time to do question 2. This question, you need your graphing calculator. It says, Lauren throws a ball into the air. She is holding the ball 5 feet above the ground when she throws it and throws it at an initial velocity of 8 feet per second. That means how fast it was going when she first threw it. The path of the ball is represented by the function h of t equals minus 16t squared plus 8t plus 5. Use a graphing calculator to sketch the graph and label all the key points, including those found in parts A through D. Now, your paper may look different than mine. I know your question asks for parts A and D, but I know your question says A and D, but your paper might be missing C and D. So I will do all of these parts to help you understand it. Okay, so first thing I want to do is I want to graph this equation. So I will turn on my calculator. Let's see if you can see that. I will press y equals. And I actually already have the equation in there. It is negative 16x squared plus 8x plus 5. But if you need to know how to enter that, in that first line, y equals minus 16 x caret squared plus 8x plus 5. And let's go down to our second one. Don't know why that's there. Let's clear that out. And let's hit graph. Let's see if that works. Fantastic. Okay, question A says, what is the maximum height of the ball? So we need to find out what that maximum value is. We are going to tap second, this blue button, second, and trace. And we want to go to the maximum value, number 4. And right here it's telling us that the arrow is going left bound. We want to go a little bit left of where we see that maximum value is. So, oh, see, my y value right now is really low. I have to bring that y value back up. There it is. Okay, we want to bring that point just a little bit to the left of the maximum point. So let's hit enter. Now it's going right bound. We're going to go a little bit to the right of that maximum point. We'll hit enter. Now it's asking us to guess what that maximum point is. So hit enter. And that looks about right. So the vertex is where y equals 6 and x equals 0.25. But the maximum height is represented by y, right? Let's look at our graph here. We have to label the part still. This is the height in feet, and this is time in seconds. This is the y-axis and the x-axis. So this calculator is telling us that the maximum height of the ball, which is represented by the y value, is 6 feet. How long did it take the ball to reach its max height? That would be the x value, which is 0.25 seconds. Let's see, so can we graph that? Let's see if 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So if the vertex, according to our calculator, is 0.25 and 6, it would be just a little bit on the inside and up to what's 1, 2, 3, 4, 5, 6. Let's do that again. It'll be 1/4 or 0.25 and 6. 1, 2, 3, 4, 5, 6. That's our vertex right there. How long does it take the ball to hit the ground? So we want to find what the x-intercept is. So again, let's go back to our calculator. Let's go second, calc, and we want our 0 values. So we want number 2, and we want it to be a little bit below the x-axis. So I see y equals negative. Oh no, let's start a little bit above the x. A little bit above the x-axis where y equals 1. Enter, right bound. A little bit below the x-axis, y is negative. Enter. Now it's asking us to guess. Enter. And it's telling us that the x value, where y is almost equal to 0, is equal to 0.862. So how long does the ball take to hit the ground? 0.862 seconds. Question, whoopsies, sorry you can't see that. Question D, what does the y-intercept represent in the context of the story? So if this is, let me move the calculator. If this is our axis of symmetry right here, and we know that one x-intercept is here, the other x-intercept must be right about there. So it looks like the y-intercept is 5. Remember, we are talking about someone throwing a ball. So I would say that this y-axis represents the person throwing the ball. Here's the ball. They throw it, goes up, and then it goes down. So that y-axis goes through. The y-axis shows where x is 0. The y-intercept is where they release the ball. So how do we write that? The y-intercept is how high in the air The ball is when the girl releases the ball from her hand. Okay, let's go to the other side. Now my paper looks a little bit better than your paper. I know your graphs are a little bit messed up. And remember, I always recommend that you do this on a blank piece of paper. There really is not enough room in this space for you to do all of your calculations. So let's start with question 3. Question 3, the equation is f of x equals negative 1/5 or negative 1/5 times x minus 3 times x plus 7. This is the factored form, right? I'm going to write factored to remind myself that that is the factored form. There are two binomials. The first thing I can do when I have the factored form is find the zeros. I find the zero of that one and find the zero of that one. So x minus 3 equals 0. X plus 7 equals 0. I do the opposite. Plus 3 means x equals 3. And on this side, I do the opposite. Minus 7, x equals minus 7. What do these zeros represent? They represent the x-intercepts, meaning when y equals 0, where does the graph cross the x-axis? So we have 3, 0, and we have negative 7, 0. We'll graph it in a little bit. The next thing that we can do when we have the factored form is we find the axis of symmetry. The way we find axis of symmetry for the factored form is we average the zeros. To average the zeros, we add them together. 3 plus negative 7, and we divide it by 2. So 3 plus negative 7 is negative 4, divided by 2 equals 4. Negative 4 divided by 2 is negative 2. So that means our axis of symmetry, or x, equals minus 2. Once we know the axis of symmetry, the next thing that we learn, or the next thing that we can figure out, if you look on your flip book, it is to find the vertex. Once we know the x value, let's plug it into the original equation and we can find the y value of the vertex. So the original equation is f of x equals negative 1/5 times x minus 3 times x plus 7. So that means f of x equals negative 1, f of minus 2, right? We're plugging in negative 2 for x. Negative 1/5 times negative 2 minus 3 times negative 2 plus 7. So f of minus 2 equals negative 1/5 times minus 2 minus 3 is like doing minus 2 plus minus 3. So minus 2 plus minus 3 equals minus 5 times minus 2 plus 7 is basically 7 minus 2. So that would be 5. So f of negative 2 equals negative 1/5 times what's negative 5 times 5 is negative 25. To represent this as a fraction, we put it over 1. So f of negative 2 equals negative 1 times negative 25 makes that 25 divided by 5 times 1 is 5, which means f of minus 2 equals 5. So finally, we can say that the vertex is equal to negative 2, 5. So let's take this information and plug it back onto the worksheet. The x-intercepts we have right here. The x-intercepts are 3, 0, and minus 7, 0. So you may have to finish drawing your graph so it looks like mine. But I can plot 3, 0, 1, 2, 3, and negative 7, 0, 1, 2, 3, 4, 5, 6, 7. My axis of symmetry, x equals minus 2, 1, 2. Just put our dotted line for the axis of symmetry. And we can plot our vertex, which is minus 2, 5. So our vertex is minus 2 and 5. 1, 2, 3, 4, 5. Now that we have 3 points, we can make our graph. This comes down this way, and this comes down that way. Perfect. Okay, let's move on to the next question. Remember, I want you to do it on a blank piece of paper because it has more space. The next question, graph from standard form. G of x equals negative x squared plus 8x minus 9. Now, I want to write this a little bit differently. G of x equals, that minus sign represents minus 1 times x squared plus 8x minus 9. Okay, from the standard form, what is the first thing that we can easily find in the standard form? This value right here, the y-intercept. Easy peasy. The y-intercept equals negative 9. That's step number 1. Step number 2, the next easy thing to find is the axis of symmetry, which is equal to, what is that equation? Think about that for a moment. Negative b over 2a, which means our axis of symmetry is equal to, well, b is equal to 8. I have the negative, so we're doing the opposite of 8. So that's negative 8 over 2 times, and what is a? A is equal to negative 1. That's why I had you rewrite that negative as a negative 1 to help you pick out what a was. That means we have negative 8 over 2 times negative 1, which is negative 2. Those negatives cancel each other out, which means 8 divided by 2 equals 4. So our axis of symmetry is x equals 4. So once we know the axis of symmetry, the last thing we need to find is the vertex. We take the value of the axis of symmetry and plug it back into that original equation. So we have g of x equals -1 times x squared plus 8x minus 9. So we have g of 4 equals -1 times 4 squared plus 8 times 4 minus 9. So g of 4 equals, we first have to do the square. 4 squared is 4 times 4, which is 16, times -1 is -16, plus 8 times 4 is 32, minus 9. So G4 equals -16 plus 32 is basically 32 minus 16, which 32 minus 16 is 16 minus 9. So G4 equals 16 minus 9 is 7. So what were we trying to find? The vertex. We already know the x value, right? That's what we plugged in here. The x value of the vertex is always equal to the axis of symmetry. So that's 4, and the y value is 7. So let's go back to our original paper. We have our vertex we just found is 4, 7. Our axis of symmetry, we found x equals 4. And our y-intercept is -9. Now, if you don't have your work on the paper, if it's on a separate sheet of paper, that's fine. You can bring that in to show your work. So let's plug these values into the graph. The vertex is 4, 7, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Axis of symmetry, oops, sorry about that. The axis of symmetry goes right down through that vertex. We know the y-intercept is -9. The y-intercept is where x equals 0, and the y is -9. So x is 0, and we have -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the axis of symmetry helps us mirror. We know this y-intercept, so that's 1, 2, 3, 4 away from the axis of symmetry. Let's go 4 the other way. 1, 2, 3, 4. Those are our 3 points, and now we can connect them. Okay. And the last problem that we have to do. The last problem is a vertex form. We have h of x. Whoops. Nope, that's not it. We have h of x equals 3 times x minus 1 squared minus 5. I hope you're looking at your flip book. What is the very first thing we can find in the vertex form? It's in the name, vertex form. Number 1, we find the vertex. The vertex is always h and k. Now, this is assuming it's a negative here. So we always take the opposite of what you see here. So the vertex is going to be 1, comma, but we take this, -5. Now our axis of symmetry is always going to be the x value from the vertex. So that's another easy one to find. So the axis of symmetry is x equals 1. Once you know the axis of symmetry, we can find the number 3. We can find the y-intercept. We take that 1, we plug it into the original equation, and we get the y-intercept. Nope, I said that wrong. The y-intercept, okay, number 3, we are doing the y-intercept. The y-intercept is always where x equals 0. So we're going to plug 0 into the original equation. H of x equals 3 times x minus 1 squared minus 5. So we're finding h of 0 equals 3 times 0 minus 1 squared minus 5. H of 0 equals 3, let me bring this up, 3 times 0 minus 1 is -1 squared minus 5. H of 0 equals 3 times -1 squared is -1 times -1, which equals 1 minus 5. H of 0 equals 3 minus 5. So h of 0 equals 3 minus 5 is -2. So when x is 0, the y-intercept, whoopsies, the y-intercept equals -2, or we write that as 0, 2. So let's take that information and plug it into the original form. So we have the vertex, we have as 1, comma, minus 5. We have the axis of symmetry is x equals 1, and the y-intercept is 0, 2. The y-intercept is always where x equals 0. So let's plot these points. The y-intercept is 0, 2, 0, 1, 2. Axis of symmetry is 1. The vertex is 1 minus 5. So the vertex is 1 minus 5. The y-intercept is 0, 2. And on the axis of symmetry, we mirror the y-intercept on the other side. This is a positive A, so we're going to go up. There we go. Let me know if you have any questions.